Okay, let's get right to it. Um, in the last video, I was trying to explain that there was a problem with adding two fractions together, and so I wanted to explore this a little further with the number line, and that's why I have this up here like this, showing the 1/6, the 1/3, and the 1/2, and of course the corresponding thing, which is less than 1. And of course, this number line continues in both directions. That's what this is. So just looking at this area here, this is what it would look like if I was only dealing with the scale of a half. If I was only dealing with the scale of a third, in other words, I removed all this clutter, and the scale of 1/6, 1/6, 2/6, 3/6, etc. What we were trying to do is say that 1/2 is being added or subtracted from 1/3. So 1/2 being added or subtracted from 1/3. Look at this. 1/2 that goes to here. Now how do you go 1/3 from here? Well, you would have to go to another scale and add that to this scale, and it would be like a kind of a guessing thing, and then you wouldn't know where you're at. I mean, even if you did it, how would you know what that would be if you put this with this? That's the problem. So what you need to do is find something that's common between these two, and that would be another scale that you can add everything up, and that would be this scale. You take the smaller scale, because this is smaller. 1/3 is smaller than 1/2, obviously, and 1/6 is smaller than 1/3, and so you can add these up because they correspond to one another. Like 3/6 is 1/2, and 2/6 is 1/3. So therefore, we can add 3/6 and 1/3, right, and get this, and get these two answers here. Now, something you might not have noticed when you did this, did you notice that we multiplied these two together to get 6? Did you notice that? Did you notice that to get 2, we multiplied this and this together to get 2? Did you notice that 3 came from multiplying these two together? I bet you probably didn't notice that. So, this will be the general. If we multiplied A times B and put the answer here, right? In other words, A times B, okay? And then we multiply C times D and put that over here. And then we multiply C times B and put that down here. Then we can add or subtract, as we were doing, these two together. And we'll get something like this. We'll get a common, A times B plus or minus C times D all over CB. That's what this is. And this always works. In other words, you can cross multiply. Sometimes people call it a bow tie if you look at the way it looks. and then you can add or subtract these two, which is what we did here, maybe without knowing it, and that's why we were able to get these answers. So, for example, if we have, I don't know, 5, 6, and we wanted to just add, we're not going to subtract, we're just going to add 5, 6 to, same thing, 1/3, why not? Then we just, according to this, we just need to multiply this times this and leave the answer here. Multiply this times this and leave the answer here. Some people call it crisscross applesauce, and multiply this times this and put the answer at the bottom. So doing that, since I'm over here already, 3 times 5 is 15. And then I'm going to add that to 6 times 1, which is 6, and divide that by 6 times 3, which is 18. It always works. Now all you have to do is just add these, and you'll get, you only need 5 more to get to 20, so this is 21 over 18. And there you go. It always works. If you need to reduce this, I'm going to let you think about it, because I asked you to remember your primes. Can this be reduced? Can this be reduced to less than 21 over 18? I'll leave that to you to think about. And that's it for right now.